Welcome, everyone. Welcome to the webinar Mango Disorders and Best Handling Practices for Importers and Retailers. My name is Natalia Tello. I'm the Research Manager at the National Mango Board, and I will be the moderator for this webinar. To start our discussion, allow me to introduce today's speakers, Dr. Jeffrey Brecht. Dr. Brecht is an emeritus professor at the University of Florida, where he served on the faculty for over 40 years after earning his PhD in plant physiology from the University of California, Davis. His research focused on post-harvest physiology, including the handling, storage, and supply chain management of fruit and vegetables, with the goal of improving quality and shelf life. In addition to his research, he held a statewide extension responsibilities in Florida, collaborating closely with industry partners. Dr. Brecht has authored nearly 900 technical publications, including 258 referee journal articles, and has secured more than $35 million in competitive funding grants. His honors include being named a University of Florida Research Foundation professor, a fellow of the American Society for Horticultural Sciences, and an honorary member of the Florida State Horticultural Society. Currently, he is a member of the Council of Scientific Advisory for the Global Cold Chain Association and the UC Davis Post-Harvest Research and Extension Center. With that being said, I want to invite Dr. Brecht to please start the webinar.
Thank you, everyone. Okay, so I'm very pleased to be here today. This is an area that I've been doing work on for quite a few years, much of it actually sponsored by the National Mango Board. So probably the majority of what I'm going to talk about are things that I've done for the Mango Board and for the mango industry. So here's the outline of my presentation. It's going to be an introduction about what I plan to try and communicate to all of you. I'm going to go through a number of post-harvest fruit disorders that you may see in the marketplace, and then I'll go through the supply chain from harvest, packing house, shipping to receivers and retail to show where these disorders may show up and what the causes are. And then I'll have some conclusions at the end. So I've had over 30 years of experience conducting research with mangoes, most of it related to international transport and distribution, dating back to a mango controlled atmosphere research project that was related to the possibility of using controlled atmosphere for international shipment of mangoes, something that I've continued until very recently, actually. So I'm going to talk about best practices and the mango disorders and how these things are related to each other. So we're going to talk about quality control in the whole scope of this talk today. That refers to all of the procedures and the record keeping that we use to ensure that the best possible mango quality and condition is delivered to customers. So these are control measures, record keeping, loss prevention activities. One of the first things I did with the Mango Board was a study that led to the production of the Mango Post-Harvest Best Management Practices Manual. That's available in English and Spanish and Portuguese. It's been updated a number of times. The most recent version is 2024. And here you see a picture of it. It was a joint project that led to this manual that included people from UC Davis, other researchers from Mexico, Guatemala, and Brazil. And we did work in most all of the mango exporting countries of documenting how things are done. So on to disorders. I'm going to break this down into disorders that originate before or during the harvest period. And these include fruit decays, internal breakdown, sap burn, sunburn and sun scald, and lenticel breakdown. And then the second category, disorders that originate after harvest. That also includes lenticel breakdown, which I'll talk about how that can be. mechanical damage and hot water injury, which is another physical damage like mechanical damage, chilling injury, which is something mangoes are subject to as a tropical fruit, premature ripening, and atmosphere injury, which is something that primarily occurs during international transport. So for fruit decays, the two most common types of decays that we see in the marketplace are anthracnose and stem end rots. These are both very important because they survive through the distribution system, and then the fungus, the microorganism, starts to become active and grow and create lesions when the fruit ripen towards the end of the distribution system. So this is what they look like. Stem end rot, as the name implies, is a rot that generally starts occurring at the stem end of the fruit and proceeding from there. It's typically related to physical injury. On the right, you see anthracnose. This is a fungus that will infect the fruit very, very early in the uh, uh, the development of the fruit and then remain quiescent or like in hibernation until the fruit begins to ripen. This, interestingly, the hot water treatment that's used for insect quarantine actually reduces anthracnose incidence and severity. It doesn't kill the fungus, but it weakens it to a point that it becomes a very weak pathogen instead of a strong or virulent pathogen. A disorder that we don't see too much in imported or exported fruit is internal breakdown. This is a disorder that has various different symptoms that are somewhat variety specific. One is jelly seed, as you see around the pit or the seed, you get a breakdown and water soaking of the tissue. Another is called soft nose, where the breakdown is mostly towards the distal end, the opposite from the stem end. And the third one is stem end cavity, where you get these open air spaces near the stem end, which looks similar to one of the symptoms of hot water injury, but it's different. The reason you don't see these too much in exported fruit is because the incidence tends to increase the longer the fruit remain on the tree and are allowed to ripen on the tree. So it's sort of one of the things that makes harvesting truly tree ripe fruit sort of a bad idea because you start to get greater incidence of these disorders. It's actually related to calcium deficiency and excess nitrogen nutrition of the trees. Another disorder that we see is sap burn. So the latex that is found in mango trees can burn the peel of the fruit. And when you harvest the fruit, that sap can be under some kind of amount of pressure so that this is someone just snipping off the pedicel, and you can see the latex or sap squirting from the fruit. So there's this pressure related to the water status of the fruit. It can be very high right at the moment of harvest, but it dissipates over time after the fruit are harvested. So you commonly see the fruit being laid down inverted so that sap can drip off onto the ground before the fruit are put into the field lug baskets, or you can harvest it with a long length of pedicel on the order of 4 to 6 inches long, and it won't spurt out when you detach the fruit. And eventually, over time, as the pressure dissipates, it'll stop dripping, and you can recut those pedicels or stems shorter. Sunburn and sun scald. So on the tree, the fruit are not really directly exposed to the sun for long periods of time because the shifting of the sun moving across the sky and the leaves and branches. But after they're harvested, they can be very prone to being exposed to direct sunlight for sometimes somewhat extensive periods. It's very, very easy for the temperature on the top surface of a load of mangoes directly exposed to the sun to heat up to 20 or 30 degrees above the air temperature to a point that it actually kills that exposed tissue and you get this sunburn or sun scald. So obviously this is a defect that should be removed on the packing line. So you uh, avoid the sap burn, like I said, invert the fruit right after harvesting them and allow the latex to drip onto the ground instead of getting onto the fruit peel. Leave long stems attached, as you see in the upper left, and the latex won't squirt out of those at the time of harvest, and eventually you can cut them shorter. You can actually also wash latex off the fruit if you catch it very quickly after harvesting. But if you wait more than an hour or so, it'll start to burn the peel and cause that discoloration. And once the discoloration is there, it can't be removed. And then those fruit have to be culled because it's not acceptable in the marketplace. Now, lenticel breakdown. This is very interesting. This is a very general indicator of stress in mango fruit. So you see lenticel discoloration from a number of different stress responses. You see it from hot water treatment, you see it from chilling injury, you even can see it from pre-harvest stress like water stress because of lack of irrigation or salt stress in the soil will all cause lenticel discoloration. So just seeing that in the marketplace, you can't see lenticel discoloration and say this was caused by chilling injury or this was caused by hot water injury. All you can really say is that the fruit were exposed to some kind of stress. And this is something that uh, increases over time after harvest. It tends to start out as a reddish discoloration of the lenticels, which, by the way, are little openings in the peel of the fruit that allow gas exchange. It allows oxygen to get into the fruit so that it can breathe and for CO2 to come out of the fruit that's produced by the breathing or the respiration. But those first become reddish and then brown, and eventually they turn black as it progresses and gets worse and worse. There's different kinds of flesh discoloration that you might see in the marketplace. There's the internal breakdowns that I mentioned earlier, which is definitely a pre-harvest disorder. You also can see internal flesh discoloration from chilling injury. Corte negro or black heart is a chilling disorder. It shows up somewhat haphazardly. Some varieties are more prone to it than others. Honey tends to be one that shows it more often, but it doesn't always occur. It's still sort of a mystery to researchers. We know that when it does occur, it means the fruit were chilled, but it doesn't always appear after chilling. So, like I said, a bit of a mystery. With hot water injury, if the injury is very, very severe, eventually you can also see internal flesh discoloration. But at the time that you start to see discoloration in the flesh, you also can see scalding and that type of discoloration on the outer peel beforehand. So you're not going to be surprised by it. Of course, mechanical damage, any kind of scars, scrapes, cuts, and bruises, these are all going to make the mango fruit unmarketable. They're not going to be acceptable in the marketplace, just from appearance to begin with, but also because they're a gateway for decay organisms to start to produce decay lesions. You also get more water loss because the injury breaks through the waxy cuticle surface of the fruit that normally limits the water loss, but also it accelerates the production of ethylene, which is the gaseous hormone that causes the fruit to ripen. So it'll promote premature ripening if the fruit are mechanically damaged in any way. And if it's only a portion of the fruit in a load, the ethylene they produce will not only affect themselves, but also the other surrounding fruit because it is a gas. Ethylene is a gas. shrunken shoulders, as you can see on the left. This is on the right of that picture on the left side is the very same fruit cut open to see what that is. That's a hot water injury symptom. The fruit are underwater for an extended period of time, and they pass through a temperature range that really maximizes the respiration rate. So the fruit produce a lot of CO2 gas, but they're underwater, so it stays inside the fruit, and that's where the cavities come from. And then within a short period of time after the fruit come out of the hot water, that uh, that cavitated area will collapse, and you get um, fruit collapse at the stem end. You also can see it deeper in the fruit, like you see on the right. This is also from hot water treated fruit. So, a practical strategy that's used quite often when this is an issue is to just let the fruit sit overnight before they're run over the packing line to allow this uh, shrunken shoulder disorder to appear, and they can be removed on the packing line by the graders and culled. Surface pitting. This is a symptom of chilling injury. It's very, very characteristic. If you're familiar with a American style football, the football itself, the surface is pebbled, and that's the appearance that you see on the mango fruit. So there's sunken areas on the surface of the fruit, and that's a very distinctive indicator of chilling injury in mangoes. Surface scald. We usually see surface scald on mangoes from the hot water treatment. So this is really something that you would usually only see if the hot water treatment was not being managed properly and the fruit were getting too extreme a treatment. And you can see that the severity of it can vary quite extensively. The fruit that show the worst symptoms here are actually from lab tests that we did where we were doing a range of water temperature and exposure times and actually going beyond what the standard insect quarantine treatment would be. So you normally would not see the symptoms this bad in commercial fruit. So hot water injury, the treatment itself, like I said, it's a very long exposure time, 60 to 110 minutes. The mango fruit are immersed in 46-degree water. And this is sort of an irony. It was developed by USDA entomologists in Florida, but they used quite advanced ripeness fruit, like about stage 3 or so on a 1 to 5 scale, so about half ripe. And they developed it with this combination of time and temperature being able to kill the fruit flies that were the number one purpose that they were trying to achieve without injuring the fruit. What they didn't realize is that less ripe and especially immature fruit are more sensitive to the heat treatment. So it wasn't until the treatment was commercialized that it became widely recognized that there was this possibility that you could injure the mangoes, especially if they were harvested too early. So you can get the hot water injury from misapplication of the treatment, which is really very rare because the treatment are typically very, very tightly um, uh, controlled and being done in USDA certified treatment facilities. So it's much more likely to be something that you see if there's immature fruit in a lot of mangoes. It was found after a period of time that if the hot water treatment was followed by hydrocooling, meaning if the mangoes were taken out of the hot water and put into cool water to cool them down more quickly, that greatly reduced the hot water injury. Unfortunately, what happened is that cooling actually could overcome the insecticidal effect of the hot water treatment. So after this hydrocooling was starting to be used by some mango handlers, we started to see some live fruit flies making it into the US. So the USDA modified the protocol so that you can only start the hydrocooling a certain time after the end of the hot water treatment, with only down to a certain temperature of water. So it's not universally used because that can actually complicate the logistics of moving the mangoes through the packing facility. So so when it is used, they have to follow these extra steps. But the symptoms of hot water injury appear fairly quickly. So, like I said before, if the fruit are rested, typically it's done overnight, so they'll be packed the next day. You'll be able to see the symptoms if there are any injured fruit, and then those can be removed in the grading process. So this is what I'm talking about, the 1 to 5 stage. It's called 0 to 4 in some places, but it's still 5 stages. So stage one is a fruit that hasn't begun to ripen yet. And then the other stages, 2, 3, 4, and 5, are basically 25, 50, 75, and 100% of the flesh area of the fruit moving from the seed outwards has started to change color as the fruit ripens. So, in fact, the maturity indices for mangoes are ripeness stages. So, the fruit should be being harvested at stage 2 at the earliest, which means they've already initiated ripening. The fruit, as they develop, they accumulate starch, which means the dry matter portion of the fruit, as opposed to the water portion, increases as the fruit develops. It's been found that a minimum of about 14% dry matter is a good target for minimum fruit development. And then those fruit, when they ripen, will develop a very nice level of soluble solids content, which indicates the soluble sugars that make the fruit sweet. So here's chilling injury. With mangoes, as a general rule, the lowest safe temperature is about 54 degrees Fahrenheit, 12 degrees centigrade. And anything below that, the fruit will potentially develop chilling injury. This is the lowest safe temperature for a fully mature mango. As they ripen, they actually get less and less sensitive to low temperature. So they can be stored at lower temperatures as they ripen. So the severity of the injury is worse with less mature fruit. It's worse the lower the temperature, and it's worse the longer the duration. So it's quite a complicated thing. You can get many different combinations of maturity and temperature and time of exposure that all can result in chilling injury. A very important concept, though, also is that the injury is cumulative with repeated exposures to low temperature. So it doesn't have to be a constant exposure. And what that means in practical terms is as mangoes change hands as they move through the distribution system, different people may expose the fruit to mild chilling exposures such that they don't think that what they're doing could possibly cause any harm. But it's cumulative, so it builds up over time. And at the end, you may very well see chilling injury, although every individual handler didn't do anything very drastic. So that's sort of an insidious aspect of chilling injury. I mentioned the pebbly pitting that you see. This is what it literally looks like. These are from lab experiments. 12 days at 2 degrees plus 2 days at 20 degrees, and you can see there's some very severe chilling injury. And then this is 15 days at 2 and 2 days at 20. You see a different variety, different appearance. So these are, like I said, these are lab tests. You would never hold mangoes in any conceivable situation at 2 degrees in a commercial situation. But it shows what the very severe symptoms look like. So there's a sequence of appearance of these symptoms also. And the one thing I haven't mentioned yet is the very first thing that happens with chilling of mangoes is loss of aroma synthesis. So that's the first thing that happens, and there's nothing to be seen. So then after that, you get lenticel discoloration. That's the next thing that tends to appear. Then you get the skin discoloration, gray or brown appearance, and vascular browning. Vascular strands are what carried the water from the plant into the fruit when it was on the tree. And then you get the scald-like skin collapse, the pitting, and the internal browning appear last. But back to the loss of aroma. The consequence of that potentially is you can have mangoes that were very slightly chilled, and so they never develop visible symptoms, but they've lost the aroma part of the flavor. They still have the sweet taste potentially, but without aroma, they basically are very bland. And so that can really have a negative effect in the marketplace. Premature ripening. So premature ripening, as I mentioned before, if the mangoes are harvested at a proper stage, they have already begun ripening. And so everything you're doing from that point on is to lower the temperature to slow the ripening, but you can't lower it so low that you also cause chilling injury. So there's a limit to how you can use temperature. Therefore, the temperature management is very complicated and very specific. So if you don't cool the mangoes quickly, you can, excuse me, I need to go back. If you don't cool the mangoes quickly and uniformly, you can have some fruit within a pallet that are warm enough that they continue ripening, and then those will become overripe fruit later on in harvest. If you don't send them at the correct shipping temperature, if it's too high, they can actually warm up because they're actually producing their own heat at the same time from their respiration. If you don't have the fresh air exchange in a marine container set correctly to allow air exchange, you can get premature ripening because you can allow ethylene to build up in the chamber. And all of these same things, besides accelerating ripening, they can accelerate decay. Because of the role of ethylene in ripening, you can reduce that effect by using ethylene scrubbers in transport containers. So you can absorb the ethylene that's being produced by the more advanced fruit so it has less effect on the population of the lot of fruit as a whole. So this is just an example, a picture showing Ataulfo, now honey mangoes, what they would look like with and without ethylene scrubbing. So it's actually a very effective way to slow the ripening of the fruit as a complement to low temperature. Then we have atmosphere injury. This is really not very common. It can occur if CA or modified atmosphere is used incorrectly. It's most commonly actually a consequence of the fresh air exchange on a marine container mistakenly left closed. So what happens is that the fruit continue to respire, they're consuming oxygen, and they're giving off CO2. And typically you see CO2 injury before low oxygen injury. A clue is when you open the doors of the container, if you smell a turpentine smell or fermented odors, it tells you that they were in a airtight space and that they didn't have enough oxygen. The visible symptoms are like this. You get discoloration on the surface. You can have internal discoloration with the low oxygen injury. This is the kind of discoloration on the right with high CO2 injury that you tend to see. So this does occur occasionally. I'm aware of a few cases where fruit were delivered, and when they opened the door, the odor hit them. They knew something was wrong, and it was because there was absolutely no air exchange during long distance shipments. Okay, so that's the end of going through the disorders, what they look like and where they come from. Now what I'm going to do is follow the supply chain from harvest all the way through the retail store, just talking about the practices that need to be considered and practiced during the mango's post harvest life. So at harvest, one of the things, like I said, temperature is super important because you need to keep the fruit cool, get them cool, keep them cool, but within very strict limits because you don't want to cause chilling injury. So it's best to harvest during cooler parts of the day and keep the fruit shaded right after harvest and when they're on the transport vehicles, and then minimize delays after harvest so they get to the packing house and through that system and into the cooling operation as quickly as possible. Minimize any delays when they get to the packing house. They should be covered. They should be going into the packing house in the order that they arrive so that the time is minimized. And this is typically where the post-harvest quality control starts. This is where we do things like measure the color of the fruit to see what stage they're at, measure the firmness of the fruit, measure the starch content for the dry matter content. Just three definitions, though, I'll talk about. Maturity, when we talk about maturity, it's the stage of fruit development in relation to its capability to ripen properly. So, as I said, a stage one mango hasn't started ripening, but it should be fully mature. If it is really fully mature, it's perfectly capable of ripening. The problem is it's very difficult to distinguish a fully mature mango from a slightly immature mango at that stage one. So it's almost inevitable that if you harvest at that stage, some of the fruit will in fact be immature. If you start allowing them to ripen, then it's much clearer what stage they're at when you harvest them. So part of quality control is to cut a certain number of fruit to get an idea of what the maturity of the fruit, what the mixture of maturities is. And then the next two, this is sort of a contrast, quality versus condition. If there's an issue farther down the line and an inspector comes in to look at a load of mangoes, they're going to refer to quality and condition, and they mean completely different things. We usually think of quality as everything that makes a mango taste good, but that's not what it's meant in the QC universe. Quality are the attributes of the fruit that don't change. So it's the size, the shape, it's like the percent of red blush, which is determined by sun exposure on the tree. Other permanent defects like scarring and russeting, those are quality issues. Condition are the things that change after harvest. So actually ripeness is a condition, decay is a condition, bruising is a condition, hot water and chilling injury are conditions because they change, they increase over time after harvest. So the things you need to measure and record, temperature, of course, you need records monitoring the temperature throughout the whole post-harvest life of the mangoes. You can measure or at least take pictures or make notes about external and internal color. You can measure the fruit firmness with a penetrometer. You can measure the soluble solids content, which is a quick and easy way to get an estimate of how much sugar is in a fruit. You can measure the dry matter by weighing fruit before and after they've been dried in an oven. You can document defects and disorders. A very important and highly recommended practice for quality control at the packing house level is to retain samples of shipped lots. So you just have to retain a small amount of fruit, but it's for the purpose if there's a complaint down the line, you have some of the same fruit that you've held back to look at yourself. And that can help you determine whether there was something inherently wrong with the fruit that were shipped or it was something done after they left your possession. So if there's a problem down the line, but you don't see the problem in the fruit that you kept behind, say in a 54, 55-degree storage room, then it was something that happened later on when they were out of your hands that caused that problem. I'm just going to have this one slide here related to food safety. And that is because this is part of the whole system, especially the record keeping, because the way that the system in the US works now is that all people who handle the produce, the mangoes, have to know where it came from, where it went to after it left their possession, and they have to have records of what the condition was when they received it and what the condition was when it left. The reason for this is if there is down the road a food safety incident where the fruit turned out to be contaminated with some human pathogen and people get sick, the FDA is going to do a traceback study, and they're going to follow back through the chain of custody and try and determine where the contamination occurred. And if you don't have records, it's much more likely that a finger will be pointed at you as the culprit in whatever happened. And when there is a contamination like this with a food poisoning organism, the product is considered legally adulterated. So that's a word that we usually associate with poisoning. But these microbes that cause food poisoning are looked at legally as a poisoning of the food product. And the people who are responsible for that, because they didn't follow proper procedures, whatever the reason is, they're going to have very serious legal consequences. So you don't want to be a person who is implicated because you didn't keep records that documented that you followed the best practices. So that's one slide, but it's a very important slide. So as we go through the system, we've gone through the system that they've come into the packing house, they've had the initial quality control measurements, they're going to get the hot water quarantine treatment, which, like I said, is a very tightly controlled process in USDA certified equipment and very tight control of the temperatures and the time. Then you have that hydrocooling if you choose to do it. So the 46-degree mangoes, that's the temperature they come out of the treatment at. They can be cooled in water that is no cooler than 21 degrees. And there has to be, I didn't write it down here, there has to be a gap of 30 minutes between the end of the hot water treatment before you can start the hydrocooling. Then they can go and be staged in some kind of a shaded area and rest if you choose to allow any symptoms that might occur to make their appearance. Then they go through the packing line. The main thing with the packing line is that they go through quickly so that you get them quicker to the next step, which is the cooling step. But this is the step where any sorting for quality and to remove defects is going to happen. This is where the sizing takes place, etc. Then the fruit are off the packing line. They're put into the shipping cartons. They're palletized, and they go into forced air cooling. The reason we use forced air cooling, it's a method that forces the cold refrigerated air in a cold room to move through the packages and through the pallets so it comes in direct contact with the fruit, as opposed to room cooling, where only the outermost surfaces of the pallets come in contact with the cold refrigerated air. The difference is between cooling the fruit to about 55 degrees in on the order of 2 hours to it taking 2 days or more to achieve the same temperature with room cooling. So the fast cooling is definitely the only way to go with mangoes. Then the fruit go into temporary cold storage until they're staged for loading onto transport containers. That loading should be in a refrigerated area so that the fruit aren't exposed to ambient temperature and potentially rewarm. So you pre-cool the shipping container, the marine container, or if they're going to be trucked, the truck trailer, and you take the fruit out of the cold room. They go directly into the cold container or trailer, and everything's great. you install temperature recorders so that there's a record during the transit period of what the temperatures were and that the refrigeration system on the transport vehicle worked correctly during the whole trip. Then the fruit are going to be transported to the U.S. They may go directly by truck, say from Mexico, and it could be only a day or two or so to get to the U.S. border. Or if they're coming from Central South America, they're going to be most likely shipped by ocean, which can take on the order of even weeks, up to 4 weeks is possible from the farthest distant export countries to various locations in the U.S. An important aspect as part of this whole managing of the control chain is shipment forecasts. Because the shipping time, especially we're talking about ocean shipping, it's not just the time on the water. You have to get the container to the port. It sits in a port container facility waiting for the vessel to come potentially for who knows how many days before it's ready to be loaded. And then the same thing can happen at the other end with the arrival of the container vessel, the unloading, the inspections that are going to be done by USDA APHIS for insects and other pests. So you can easily add a week or more to the shipping time from all these other things. So if you can forecast your shipments so that they match up more closely with the shipping schedules of the carriers, then you're going to minimize those delays and you get the fruit to the marketplace more quickly. A little more detail on the loading of the transport vehicles. So, like I said before, the ideal is that the fruit come out of a cold room, they go into a refrigerated loading dock, they go into pre-cooled refrigerated containers. That's the ideal. You never break the cold chain. If you do not have a refrigerated loading dock, then you don't pre-cool the containers, the reefer containers. And this is sort of a little bit something people don't grasp this sometimes. It's because the warm outside air is going to come into contact with the cold surfaces of the pre-cooled container and water will condense and start dripping everywhere. You can potentially get the shipping cartons wet, which compromises their strength and they can collapse in transit and the whole pallet fall over because of those kind of things. So you don't pre-cool the container if you don't have a refrigerated loading dock. So that's important. You should have a refrigerated loading dock, but if you don't pre-cool the containers. The equipment itself, the transportation equipment, needs to be put through a checklist of the equipment, the reefer or refrigeration equipment itself, looking inside the container to make sure that it's been cleaned, that there isn't damage like a damage to the wall that exposes the insulation. Because if the insulation gets wet, it loses its insulative properties. So you have to do this kind of inspection before you load the container. Next is how the mangoes are put in. And according to my brother Pat, who works in the same area but on the commercial side, improper stowage is a leading cause of temperature induced diseases and disorders of mangoes. And it's because it disrupts the air movement inside the container so that you don't get proper removal of the heat from the fruit that they're generating by their respiration while they're in transit. So they heat up and you don't get the benefit of the refrigeration. So proper stowage is that everything is squared away and tight so that the air in a marine container, the air moves from the floor up. So you want the air to move through the mass of fruit. Pinwheel style is where you turn every other pallet 90 degrees, and that's not recommended because it creates air channels, vertical air channels that allow that refrigerated air from the floor to bypass the produce and go straight back to the refrigeration system without cooling the fruit. The other thing, of course, is that the packages have to be stacked straight. They have to be designed strong enough to begin with, but they have to be stacked straight and completely on the pallet. Otherwise, they can fail. And of course, if they get wet, they'll fail as well. So there's the pinwheel. I just wanted to mention that the Mango Board sponsored a study to design a standard shipping carton for mangoes, and this is what it looks like. This is designed for optimizing that air movement both vertically in a marine container and horizontally in a truck or in forced air cooling. Very important that the air can move through the fruit because that's the only way you can remove the heat. Temperature recorders. Temperature recorders are very important because they tell you if anything went wrong during shipping in terms of the temperature. We recommend, it's not done very much, but we recommend that the temperature recorders not only be inside a shipping carton, not on the wall, not on the outside of a pallet, but also that there be multiple recorders within the load, like front, middle, rear. The reason is that you want the temperature that you're measuring and recording to be as close as possible to the actual temperature of the fruit, because that's what's important. One of the big types of cases that my brother runs into is loads that are erroneously rejected because a temperature recorder that's only measuring the air temperature shows that the temperature went too high when it's not measuring the fruit temperature, which actually changes much more slowly with changes in air temperature than the air temperature itself. So you should be measuring the fruit temperature as nearly as you can to to make the best decisions about what to do with the fruit. You have to specify all of the conditions. And I'm not going to go into these in detail, but it's basically temperature, airflow, humidity. Basically, you shouldn't specify humidity setting in a container because they only have dehumidification. With energy saving reefer containers, these are ones that allow the temperature to drift so that the reefer unit is not running as often as possible. We don't recommend that you take that option at all with mangoes. It should be maintaining a steady temperature all the time. We have a brand new publication that just came out last month. It comes from UC Davis, but my brother Pat and I are both authors on this as well. Transportation and Destination Handling. So this is brand new off the presses. You can get it from University of California. Has a lot more information about transportation and handling. Okay, now we're at the destination. So we're at the distribution center. There has to be another quality control inspection, the arrival quality, and this is like sort of the reverse of the initial quality control. You need to have consistency and a very standard procedure to be followed the same every time. In some cases, the fruit may need to be reworked, especially if it's a load of fruit that's being sold on consignment. It may turn out that the buyer, whoever turns out to be the buyer, has some kind of special requirements, and that means that the pallets have to be taken apart and fruit removed and repacked. So that has to be done in a refrigerated container, a refrigerated area, following food safety practices as well, sanitation and all. Then you have storage. The storage is the same. It should be the same 54, 55 degrees or as close as possible. With the fruit either first in, first out, or if you are a little bit more advanced, you can take information about how ripe each load of fruit is and send them out different times to different distant destinations based on how much shelf life is remaining. So that's FIFO, first expired, first out logistics. And you have all the same quality control of the destination as I measured before. There should be a protocol that you follow for this, and we actually have a lot of information about that in that post-harvest best management practices manual in the appendix at the back, a sample quality control checklist and the types of pictures you should take and all of that kind of information. Now we're at ripening. So mangoes ripen best at 68 to 72 degrees, which is 20 to 22 degrees centigrade. And that's where they achieve their best combination of color and texture and aroma. However, something that came up not that long ago is that some ripeners are using banana ripening schedules. And so there's the potential, which because those are much lower temperatures, that could be damaging the quality of the mangoes. We looked into that, a research project sponsored by the Mango Board, and we found that if the mangoes are in a banana ripening room just for the initial 24-hour ethylene exposure, and it's at a low temperature, say 20 degrees, in the long run, that doesn't end up having a negative effect if the rest of the ripening occurs in the 68 to 72 range. So what's happening? I've mentioned the mangoes are already ripening if they were harvested at the right time. But what's happening is you have a mixture of ripeness stage mangoes. And so the ethylene treatment speeds up the less advanced fruit so that overall you have a more uniform lot of fruit that is at the full ripe stage sooner, and they're all more uniform. Okay, more at the distribution center. Everything now is the reverse of what was happening at the origin. Now they're being sent again to the final customer. So it's all the same in reverse. The loading is all the same. This is the same slide as before, just miniaturized and repeated. At the retail store. So at the retail store, there's really no good reason for mangoes to be stored at the retail store because you can get shipments depending on the retailer every day to at least 5 times a week. So they should be brought in and sold the same day in almost all cases. If there's fruit that are being held back from being put on display, it's best not to put them in a walk-in cooler because those typically are at 5 degrees and you don't want to have the last chilling exposure be your fault at the very end. Just keep them in the back room at the ambient air conditioned temperature and that'll be fine. And then finally, when they get put out on display, they shouldn't be put in a refrigerated display. Although I don't think I've ever seen that actually done. They should be as close to ready to eat as possible. Put out at ambient temperature so that the consumers can smell the aroma. If you put out a range of size and ripeness stages and varieties, then people can choose what is their preference, and then just rotate the displays during the day to keep only the best quality fruit out there on display. So that's the end of the journey, and the conclusions are mainly I can't emphasize enough that temperature management is where maintaining mango quality begins and ends. It's all about temperature management. Anything else you do is a supplement to temperature management and maintaining the cold chain. With the problems that appear during ripening, you need to be able to recognize what they are. Failure to ripen is probably immature harvested fruit, especially if they get chilling injury. Shriveling is from water loss. Poor flavor can be also immature fruit, and chilling injury can also be non-optimum ripening temperatures, too low ripening temperatures. The chilling and hot water injury symptoms, now you know what they look like. The decay development, that's something that is really a pre-harvest issue. That's where the control mainly needs to be done. Everything after that with the temperature is slowing the development of the decay. So you just need to learn to recognize when the different problems are likely to have occurred and specify everything what you want done to the suppliers, the transporters, the receivers, everybody, and then just follow practices that will prevent additional problems, starting, as I said, with temperature management. So the choice is you either proactively prevent problems before they start, or you reactively try to figure out where the problem started and put the fire out after it's already too late. So obviously the first choice is the better one. And I just thank the Mango Board. As I mentioned, almost everything in here is thanks to the Mango Board for supporting and funding all of those investigations that led to this information and recommendations, especially Leo Ortega, the research director, the research committee that agreed to fund a lot of this research, the industry for cooperation. And I've mentioned my brother several times. He's a consultant in the post-harvest area. He worked for many years for um, United Brands, for Maersk, for American President Lines. So now he's a consultant in that area. And there we go. Thank you.
Thank you so much, Dr. Breck. We have time for a few questions. The first one we have is, can the minimum recommended temperature for storing and refrigerating mangoes vary according to the variety?
Mm-hmm. So I tried to simplify things and just use one temperature. It's a safe temperature for basically all varieties, all conditions, unless we start talking about Southeast Asian fruits, which are even more sensitive to chilling injury. Um, I didn't want to get into the temperatures for riper fruit, but it's in the best management practices manual. So you can get that specific information there. You can basically go down to about 45 degrees Fahrenheit or 7 degrees. And, the mango board may not like to say that too much because people forget that that's only for ripe fruit. But there is that range, and you can get the information from the manual.
Yeah. And I think that's something important to know is that more immature fruit is going to be a lot more sensitive to those heat and cold damages that we see across the chain. An additional question is about internal breakdown. Does the hot water treatment have anything to do with that, or what would you recommend to avoid it?
Well, in my experience, you can get internal discoloration from hot water injury, but I wouldn't say that you get internal breakdown like the pre-harvest disorder where the flesh turns translucent and gelatinous. I haven't seen that as being caused by hot water. And the discoloration is very rare in my experience. It has to be a very, very severe hot water injury, and you almost never really see that commercially.
Perfect. So that's mainly just a pre-harvest issue then,
Yeah,
if they're actually
if
seeing
you see that
collapse.
kind of translucent flesh, that's the pre-harvest disorder.
Perfect. So a question here, it's talking about green keep varieties. It's saying that they have a percentage of fruit that has a stem end softening.
Yeah.
And is there any appropriate post-harvest time for its hot water treatment? So do you recommend any particular time for that hot water treatment or resting them for a particular time?
What Well, that softening sounds again like another one of the internal breakdown disorders, not a hot water treatment, but it it reveals itself after harvest as the fruit continued to ripen. So, this may be a case where someone needs to contact me later and give me more details, but I'm not sure that that's actually a hot water issue.
Yeah, because stem end is mainly a pre-harvest issue as well.
Mm.
Mhm.
Yeah. Unless
Perfect.
by stem end softening they mean the collapse. That's an issue related to fruit maturity. It's mostly fruit that are too immature that
Mhm.
develop that symptom.
And that is during the hot water treatment as well?
Yeah, that's the hot water injury that causes the cavitation at the stem end and then it collapses afterwards, just in case that's what they really mean.
Yeah, that might be because they're talking about immature keats. So is there any way that you can prevent that?
No, you can't
No?
present that because that's a symptom that occurs from the required hot water treatment if the fruit are too immature.
Yeah. So another question we have here is there any maximum amount of time that you recommend leaving the fruit out after harvesting in the sun before you move them to the packing house?
Well, the simplest thing to do is to just leave them overnight and pack them the next morning. I mean, that's the
Mhm.
most convenient thing to do, but I don't really have very specific. It would be time and temperature. I would say, just off the top of my head, it takes at least 6 to 8 hours to start to, under general ambient conditions, to see the hot water injury symptoms start to
Yeah.
appear. But at that by that time you're in the middle of the night maybe. So that's why it's more commonly just leave them overnight and pack them the next morning.
Okay, perfect. A final question that we have is how are the selection criteria for mangoes at the packing house defined? And is there any place we can access that information?
I didn't miss I missed the first part of that. How is what defined?
The selection criteria for mangoes in the packing house.
Okay.
Mhm.
So there's no grade standards, USDA grade standards for mangoes. So it has to be based on the eventual buyer saying what their standards are and what they require. And that's difficult if the mangoes are on consignment because you don't know at the time you're packing who the eventual buyer is. But it's a basis. It has to be done on a basis of what the buyer specifies that they will accept. I think in general, any hot water injury symptoms are not acceptable. Any physical injuries like cuts and scrapes are not acceptable. Um, any clearly immature fruit, like fruit that by the shape you can see that they're very flat without shoulders, those should be culled. Those are the obvious ones that no one is going to accept. But beyond that, like the color stage and whether they'll accept a small amount of surface defects or things like that. That's got to be case by case, depending on the sales.
Perfect. One question is how fast do you see those sunburn symptoms on the fruit after harvesting?
How soon do they appear?
Yeah.
Yeah, they they appear very quickly. Um, so as the tissue is being damaged, you can see the beginnings of it. It gets much worse as the fruit ripen over time because that area tends to not ripen. But initially, you can see like a dehydration on the surface. You have to get, I can't explain it more than that. You have to get familiar with it to know what it looks like, but you can pick it up within a couple of hours. So they should be able to be culled off the packing line if the grading the workers are familiar with that. Obviously, it's better to avoid it in the first place.
Perfect. So that's the end of our Q&A session. Once again, thank you very much, Dr. Brecht.
Thank you for inviting me.